This is very interesting. You know, most of the time when people talk about the IoT, they talk about the bottom line improvements. It's all about improving the operational efficiencies. That's the number one. Improving the customer experience and strategic decision making. Bottom line operational efficiency, which is exactly the bottom line growth, bottom line improvement. You want to save money. So the cost, quality, security, predictiveness, right? Safety. This is the five most important thing to any enterprise, any enterprise. And IoT is supposed to address that. But increasingly, I must tell you this, people are also looking at IoT to generate extra money, use it as a new revenue stream. How? Well, you can provide them some smart services. You could be an aggregator and provide the services. You could be an aggregator just like, uh, we all know the Airbnb, we all know the Uber, Lyft, all those companies, they have been doing that essentially IoT monetizations, right? Monetizing your assets, monetizing your locations, monetizing your propensity to buy certain things, and then they leverage that. So IoT monetizations already exist. Right now, it might have taken a hit due to the COVID itself, but it will definitely come up in some fashion. May not be exactly the same way, some fashion will come up. Now, so when I make this particular presentation deck, I try to cover both the technology, or dance around, I should say, both the technology and the business aspect at the same time, as much as I can, because the time is only 30 minutes, right? Now, if you look at it, you know, you see this is the situations currently we are in. This is what we call modern digital business. And first one on the left hand side is customer is obsessed. Yeah, right. Think about yourself in your smartphone. How many apps typically use typically in a day? Maybe 8 or 10, right? How many have installed? Maybe 50. How many of the apps are typically there in Apple store or in the Google store? Maybe millions, right? So you exactly know what you want to have, and you have your journey accordingly. You do not get biased by any kind of a product marketing BS. Can somebody be mute? All right. Okay. So the customer is really obsessed, right? And they create their own journey. They need not be told. They create their own journey based on the frictionless experience. So that's the key thing. And you can see another one, test and learn culture, right? Test and learn culture. Think about it, television took over about 35 years to come to the mainstream. Telephone took about 27 years to come to the mainstream, like adoption of the technology itself. But Twitter took just 2 years, 9 months actually, to come to the mainstream. Pokemon took 19 days to come to the mainstream, right? So the adoption of technology which has taken decades for TV and telephone and televisions, right? Now it's like question of a couple of days. So that's what the test and learn culture is all about. And you see that technology is at the core. Second point. This is my favorite. How can I connect my data securely and handle the data they generate at scale? You see, whenever you want to talk about this vast amount of data which a typical machine produces, just to give you an example, a Singaporean Airlines flight from San Francisco to Singapore generate about 17 petabytes of machine data. 17 petabytes of machine data. That's what it does. And you know, the loss of, they call airlines on the ground, AOG. We are all used to, when used to fly, we all used to plane being delayed. Plane delay is usually $140,000 per hour. So that's a real money. And plane doesn't get delayed just like this. Plane gets delayed because of the malfunctioning of the machines or not available of the parts and so forth, right? Or the as well as the pilots and air crews of the world, right? So question is that this vast amount of data has to be securely handled. So we need to have an identity service. So essentially, there has to be a platform approach The platform must provide you the identity service. Platform must provide you the device gateway, right? Platform must provide you the series of message broker itself. Then platform must provide you a some way to craft smart rules engine, very, very important, which can be deployed on the device itself. You can develop somewhere else, but you can deploy on the device. So device has to be smart. Remember, these days edge is very smart. In the edge itself, we can have a complete database installed. In the edge itself, we can have the LWM, that lightweight protocols, both server and the clients installed. Edge is smart, right? And in the platform function itself, you temporarily touch with, the device management, lightweight M2M. And this is one is that I think uh, association for the mobile open mobile appliances, of course, MQTT, we are all used to it. And the connectivity management as well. And the connectivity management, then there's a over-the-air support, over-the-air upgrade, over-the-air patch mechanism, over-the-air registration, authentications, everything has to be done on the application management. Then there has to be a support for the monitoring and support for the service enablement. Key thing is the zero-touch provisioning. Remember, anything if you want to provision itself, if there's a manual intervention, you are dead. Nobody has time to do any kind of manual stuff. Why? Because you're talking about hundreds and thousands of the devices on the factory premises, on the hospital premises, on the retail premises, on the transportation premises. You just can't afford to have a human being going over there and install the stuff. Those days are gone. The moment it is powered on, it is supposed to send you a request and supposed to wake up by itself. So that's what is called zero touch provisioning, right? So these are the key elements one must get used to understand. And this is what an IoT platform is expected to do. So be it Amazon, be it Google, be it Oracle, be it Microsoft, anybody vendors IoT platform applications must support all of them. There, of course, there are open source IoT platform applications there as well, which is called Predix, done by GE. That's an open source IoT platform too. That also works, right? So bottom line, in the device management, the foundations, the provisioning, the authentications, configurations, control, loggings, all the over-the-air services, OTA services. Over-the-air is a key thing. You just can't afford to have an upgrade anymore by somebody going and physically patching it up. Think about Tesla car. It's just a device. It's an IoT device, really. Every day, every alternate day, it gets upgraded. The software patch itself. So it's the software. So the question is that this is where the IoT is heading to. That is the key things one must understand. And I want to just briefly touch upon, and I'm sure all of you are in the technology side as well and extremely good in the communications protocol. But these are the two protocols, MQTT and lightweight M2M. These are the two really heavily used for the IoT itself. That's key. What exactly is this MQTT protocols? Is TCP based, okay? Whereas lightweight is based on the UDP. And security, this one supports, SSL certificates, right? And DTLS is nothing but one step ahead of the TLS itself, right? So from the security standpoint, I personally feel lightweight M2M is going to provide the connectivity, the thing we must need. All of us need actually. In fact, this lightweight M2M initially was built on the what is that called? Uh, Constrained access protocol, COAP, right? But right now they support the additional transfer protocol as well. So constant application protocol was the first one lightweight M2M used to do. So these are the essentially two main protocols I have seen personally, which edge devices get connected to. Second one, digital innovations driven by the serverless microservices. And this is another favorite, this is a paradigm shift. Since the technology happens to be at the core, since everything is driven by the microservices or the Kubernetes and the DevOps oriented, right? You just don't need to have so much of big application development group. It's just so gone are the days of the monolithic application development team with a bunch of developers and project managers and architects all over the places. Everybody is kind of right now. The culture is that it's like a services. Everything is very API driven. Everything is a microservices. No longer there are a bunch, huge 10,000 lines of code. There's always 100 lines of code or 40 lines of code. It does a specific job. There's a specific way to call that particular REST point or APIs, and you communicate. So yeah, maybe over time you can see, oh, there will be a jungle of API services all over the world. There may be some startup there which are there just to manage the APIs. That's possible. But right now, that's the culture because the agility is the key to deliver the services. Agility, how fast you can deliver services in the cloud. Cloud, everything is all about speed. You just can't take 6 months job to develop some applications and having a release cycle every other year. Absolutely not. Maximum 2 weeks to 3 weeks every time there's a new services coming up, right? So that in order to be agile to support the services, you got to support the open systems. So gone are the days of the vendor locking. I won't strictly say that whether vendor locking is still not there. It's still there, but I will come back there when I'm talking about Industry 4.0. But but one thing you must remember that the development of applications, development of programming is essentially all serverless architecture. Now another one is the LP1. Okay, low power. Low power is the key, right? Why low power is the key? Because you want the sensor data to travel miles, right? With a low battery power. So as a result, it's a very simple metaphor, right? You want your water to travel, let's see, 1 kilometer distance. There are only two things you can do. You can either increase the pressure of the water, or you can have the decrease the bandwidth, make the narrow pipe, right? Exactly the same way. Either you can have a narrow bandwidth, or you can have this one, the more frequency, right? So the thing is, when we are talking about this kind of stuff, right, it's very important that it, this devices must operate on its own with a low power for a long period of time. For a long period of time. That's why the low bandwidth is key, because low bandwidth with low power and longer battery life, it does the coverage. And as you can see, this narrowband IoT, LTE, LoRa, Sigfox, all of them support this low power wide area network. And this is because without this, it's kind of difficult to, how do I say this? It's really kind of difficult to do a good job, because wireless one used to be the design to connect user and businesses, where you need to carry more data and naturally it uses more power. But here the LP1 data rate is typically ranges, if I'm not mistaken, it's about 0.3 kilobyte per second to max 50 kilobytes per second per channel. So as a result, it has a low bit rate, right? And this is what you need to understand, that remote, long-term, spread out IoT application typically faces this kind of problem of simple physics, which I talked about. And this way, with a low bit rate, with a battery power, I can sustain for a long time. Then comes the wonderful things called 5G, right? How is 5G differs? Okay, 5G actually does the same job pretty much what this LP1 does, pretty much. And it really shake up the entire LP1 landscape. Why? Because it promises low latency, it promises low power, it promises high data transfer, because low power and high data transfer are the two kind of an oxymoron. It could not be attained before. It was kind of a very difficult to do it. But 5G promised that. Low power, high data transfer. And again, they're saying low latency. And low latency, that's something, it's very funny, because if you go back to any conference or something, you see that something smart things are happening, or Mr. Trump is saying something crazy stuff and somebody just jumped. When as a viewer, you view it only after 30 seconds, because it takes time. It does take time to transfer the chunk of data over the wire or wireless. It does take time. And low latency is all about that. So 35 seconds, 30 seconds is very, very normal. Now the question is that what is normal for a given industry may not be normal for something else. If you're talking about robotics, if you're talking about welding machines, you are talking about the advanced surgery, right? Yeah, 5 seconds may be acceptable, but more than 5 seconds, absolutely not. So the thing is that the definition of seconds, definition of latency really changes over time, and depending on the applications. So you can see the critical applications which really requires a low latencies. 5G is fantastic for that. Otherwise, you can have 4G LTE, as you can see in my picture, the kind of 4G LTE coverage. But the 5G does a lot of smart jobs. Especially we're talking about the surveillance and things like that. There's no other option but to use the 5G. So edge computing is what? So coming back, moving from the data centers to the center of the data, right? That's what is. So whether you have a private cloud or network edge or compute edge and device edge or things or any endpoints, that's where things are moving, right? And edge could be a simple 8-bit, it could be something bigger than that. And as long as it has got smartness, meaning it has got some storage, it has got some capabilities, you should be fine to use those edge devices. As I said, the cloud vendors are pushing themselves towards the edge because that's what they can make money, that's what they can expand their business. And you can see that as a result, edge becomes more and more smarter. It has got more sensors, it has got more way to connecting and supporting various kind of protocols. Now gateways also having the AI itself, right? There's a cloud there, and there's a neural network algorithms on the gateway side that can be now ported back to the IoT devices. So things are getting really smart every day as I speak, every day, right? And this is the edge. So the edge, the whole thing has become a smaller form factor. It has got advanced security. It has got AI setup, low power. All of them are there. All of them are there. And that's what the things are all about. Now, second is the all right. Can you hear me? Did I lose?
Yes, sir. Yes, sir.
All right. So sensor evaluations, right? That's also another thing. If you look at 3 years back, the kind of sensors you get now is very different, because the sensors are there everywhere. This traffic light looks like it has got a temperature sensor. The building has a pressure sensor. The accelerometer is there. Digital compasses are there in the vehicles itself, right? Humidity measurements there is just on the road trees. So the thing is that sensors evaluations are there, and there's a proliferations of sensors. The and the more the proliferations, right, more is the chance of being hacked. And it comes down to how can I extend cloud capabilities to the edge? Because so far we covered certain aspect, right? Okay, how do I get the data securely? How do I manage the edge? Now the question is, on the right hand side, I have got the fantastic cloud applications, cloud platforms. How can I get the cloud capabilities to the edge? So that's a key. Message broker we talked about. Now Lambda. Lambda is a fantastic architecture these days. Fantastic architecture. Because why it is? Because it is typically a T junctions. It can do a real-time streaming. It also can do a batch stuff. You can get both. You can get both at the same time. The idea is that all those capabilities, you want to have a both synchronous operations as well as asynchronous operations on the edge itself. Sounds very techy. I'll give you a simple example. Suppose you have got a bunch of devices scattered all over the places, right? And some of them are not functioning. What does it mean? How can you make it function as a standalone? And whenever everything sets up properly, it will automatically synchronize with the cloud itself, right? So both synchronous and asynchronous replications has to be supported by the edge devices. And this particular thing came into the picture. Remember, I was working with the Indian Railways, and there was a parliament, there was a question, what's the average speed of the Shatabdi Express? Believe it or not, there was no definitive way to answer that. It took almost 15 days for the railway ministry to get back with the reply. Okay. Why? Because there was no sensor those days on the engine itself. With VSAT, it can connect and understand the speed. No, it was not there. Now it is there. Now we can do so many wonderful things just because you have a sensor there. You can proactively, predictively do magic, really, literally magic. Now, machine interference connectors, all those things you want, all the cloud capabilities you want to the edge. And as a result, the whole idea is that you you develop the things on the cloud, but you infer at the edge. So that's the kind of a shift we are seeing right now from the cloud vendors. So you can have all kinds of fantastic cloud tools to develop AI, ML, all those kind of technology, but you infer the thing at the edge. You seamlessly put that same model back to the edge itself. So edge becomes a kind of a edge does not create the model itself. Edge uses the model which has been created by the cloud. I hope I'm making it clear. So the key challenges at the edge itself is deploying the edge agents. This is really hard technology here. Identify the class of the agents and updates. Imagine you've got so much, 10,000 of sensors. How the heck do you upgrade the firmware over there? It's difficult. You got to really understand the VPN tunneling, all those protocols. You have to really understand, and you have to do it security, security, and security. Very secure way. And of course, low power. Now, coming back to the application itself, what kind of applications? Yeah, I put this logic. There is no compression algorithm for experience. Experience still rules. Remember that. Experience still counts. So people with seniority and experience doing the engineering job in the field itself, manufacturing sites, they don't have nothing to fear because that experience counts. Now it can be helped with the technology, but experience does count. And you can see that security and surveillance is across the world is the number one applications for IoT. So you see the security and surveillance, right? It's all about preventions. It's all about predictive. It's all about those kind of things, right? Then the tracking and tracing. And for the COVID, it's it's no brainer the why tracing is so important, right? And tracking of the assets, whether you are shipping goods, shipping perishable things, shipping whatever, ability to track the truckers, track the drivers, profiling the drivers from the best driver to the worst driver, geofencing, fraudulent activities, spiffing, stealing, all those kind of things can be wonderfully done these days. Absolutely. And then energy and utility management is another area itself. People are developing a tremendous amount of IoT applications because energy is becoming very interesting. If you have got a solar panel, you actually sell the power back to the utility company. So you don't pay money. On the other hand, you get the money back. And autonomous operations typically in the car itself or in the supply chain. So building style, building blocks, for developing IoT applications, pretty much visually drag and drop interface. All the cloud providers or IoT platform providers, they provide that. The models and multi-step windows there, and deploy to the other devices too, right? So, in terms of industry, I don't know how we're doing with the time. In terms of industry, we can see the manufacturing still rules, energy is another one, and the transportation industry still rules. Retail also pretty much, very much there, because retail wants to have as much of automations as possible. Automation seems to be the key here. Other industries also coming up. This is important to know that you just can't have a one size fits all. It has to be verticalized if you want to develop an applications there. Look at this digitization of the car itself. It's very, very well documented, well known how many things it can do and how it really helps other industry as well, from the insurance, from the driving school, from the parking garage, from the filling stations, all over the places, right? It supports all kinds of industry through this. This is a huge, huge impact. Last one, I think my favorite one is the IoT security. Typically, frankly speaking, it is out of sight and out of mind. Nobody cares. Nobody really pay attention to this, believe it or not. This is true. Why? Because auditing is kind of iffy, security dashboards iffy, detect is iffy. Everything is iffy in the security side. And Dr. Roy is an expert on security. He can teach you much more about it. But frankly speaking, IoT security is the one place very vulnerable. And reason being, it has got limited device functionality. Again, there's no human control there. Lack of standards. I have been associated with the industrial IoT consortium standard body. Believe it or not, there are right now 250 vendors there, and everybody has their own spin to it. So when you have got a standard body with a 250 uh, vendors, right? You just can't achieve anything. So far in the last 3 years, we haven't achieved much, frankly speaking, the lack of standards. Everybody wants permanent internet connection. That's a very vulnerable areas and weak user password protections and scale and complexity, right? So there's a huge IoT security challenges, and that's also one of the reasons why besides manufacturing, every other industry is kind of leery about it. What needs to happen? You got to provide the least privilege. You got to have a micro segmentation. You got to have an active threat detection. You got to have an end-to-end trust model. You got to have all of them if you want to have your IoT to be successful, because security really rules. With your simple things, vulnerability like your smart meter at home, they can hack your private accounts. And that's what is happening all over the places. So, last but least, that nothing gets smarter without the data itself. You get this huge, vast amount of data. As I said, the cloud guys are very smart, cloud vendors. They're now focusing on the edge itself because edge computing, IoT, that can really lift the old grandfather's company to a different level altogether, right? Which is great. It can address the cost, address the predictiveness, address the quality, address all kinds of wonderful issues. But the analytics is the name of the game. Why? Analytics is like a stock, Data without analytics has no value. But when you put the analytics on the top of the data itself, it has got value. And just like stock, it multiplies. The more analysis you do, the more you get the golden nuggets. So that's what they call very abused word these days. Data is the new capital, but that's what really it means. Because capital means you need three things, right? Typically, you need the human resources, you need the finance, you need the physical infrastructure. Now you need the data itself. So that's why they are talking about data as the new capital, but it really means the analysis. And that's what the real money is. The predictiveness, and prescriptiveness. Nobody gives a damn about what happened yesterday. What happened, typical reports. Yes, what happened makes sense if the tomorrow is the same as yesterday, then you can do something about it. If the tomorrow is not same as yesterday, you just can't do anything about it, right? And predictiveness is what happened, why happened. Yes, why happened good. If tomorrow is same as today, then why happened makes sense. But if the tomorrow is not same as today, why happened, whatever, right? And what needs to happen is the most important, the prescriptive. And that's what it's all about, because insight is great. But the insight, unless and until it feeds back to the system or the record source or edge, it has kind of iffy, right? So this is what it is. And I do not know again about the time. I'm just going on. So what we need to do is listen better. Listen better. All omni channels, I must listen. I must get the data all kinds of ways. I'll give you the backgrounds. Learn faster. You got to have an algorithm to figure out how do you learn faster and of course execute smarter. Imagine you're in the dairy of in a big market or somewhere else itself. And if the chicken is about to spoil or the fish is about to spoil, and before 4 hours it starts doing a ping, 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 I'm going to get out, I'm going to be bad. What your job should be to discount it 50% so that you can just get some money out of it, right? So these are the tremendous amount of things are happening. Imagine shopping cart abandonment, and I will get back to that. So essentially, machine learning train optimizing the cloud and infer at the edge. That's the real goal. Now IoT 4.0, I don't know if I have put the time or not. Sabasat, you can tell me to stop. IoT 4.0 I want to touch upon because this business of the RTU and the SCADA of the world, they have been there for a long time. It is making 0.4 trillion. Now it's going to be huge. How do we get there? Well, this is the term, 2012 in Germany, it has been called Industry 4.0. We all understand 1.0, 2.0, 3.0, and 4.0 is nothing but getting all those things connected together, right? So the robotic process automations, the cloud and cybersecurity, cognitive, all of them are there in the part of the Industry 4.0. So a lot of tremendous amount of theory there, no question about it. But the hard reality, the field is complex. You can see this. Less than 1% of the devices are connected. Interoperability, less than 1% of the data are kind of being used. So the people are questioning, the bosses are questioning, CEOs are questioning, why the heck I should spend money of IoT? Why? When I cannot even use my existing data itself. You see? Why the uptake of the IoT 4.0 is so low? This is one of the reasons. Existing data from the existing transducers or sensor may not be smart, but existing sensor transducer data even cannot be leveraged right now. Why the heck I have to spend so much of money to get some new stuff? Smart edge, right? So, so field level integrations, varieties of vendors, varieties of software. And as I said, there's a tremendous amount of vendor locking here. None of these guys, they support any open APIs. It's all proprietary protocol. If you pay the money, they will provide you the information. They have all the informations, but they will not make it available to you. And it's proprietary as well. So there's a definite amount of vendor locking there in this side. Same with the data destinations. We all talk about multi-cloud vendor platforms. I work in a cloud company, right? It's hard, right? None of the cloud really talk to each other. None of them. Okay. Definitely not at the SaaS level, maybe at the infrastructure level somewhere. So the open source OLF, the Linux Foundation itself, they're trying to do something about it. So they understand the issues we have in terms of multi-cloud issues, in terms of vendor locking issues on the edge side. They're trying to have an architecture where they want to remove those locks. Okay. Now, Linux is very successful, as we all know it. Whether they will be successful in the edge, we just do not know. So this is the kind of common use cases, as you see, as you can see, asset tracking, utility, predictiveness, patient monitoring. These are the 5 top use cases across industries, pretty much. And for the manufacturing itself, as I keep saying, is the quality, cost, predictability, safety, and security. The 5 things are most important. Now, how do we get there? And people have been doing it. I know in India itself, I have been personally involved with welding manufacturers to predict the welding outcomes, safety, securely, predictability, and so forth, and the yield, real time, right? So if you are successful, and I'm involved in that, and I think, and I'm also involved in the British Petroleum tracking of the vehicle itself. I'm also involved in one of those very well-known hospitals in Calcutta itself, which is Institute of Neuroscience, doing the gait movement, the gait of Parkinson's patients before and after medication, how they do versus a gold patient like me. What's the differences? So they used to have a $25,000 mat, the gait mat, and we are trying to replace that with a $250 equivalent of the wearable gadgets. So this is some interesting things are really happening in India and everywhere else. So data management challenge, both IT and OTs, it's pretty much, as I said, incomplete view of the manufacturing process, because difficult in accessing the real-time data. There's several PLC and historical data set, and of course the very distributed systems. One ERP, somebody else's, supply chain, somebody else's healthcare application, somebody else's HR application, somebody else's CRM, all over the places. So it's a real challenge there. So you can make it, smart products, smart factories, smart way of doing things. So you can have a data centric approach, because that's the only way you can make some sense out of it. And then you can build you can have analyzed data over data over data, so you can multiply the data values through the innovation itself. So that's why I'm saying data is becoming like a stock. It is not one thing. When I say fuel, right? Fuel has got a very funny connotation, right? You have some petrol or diesel, right? It has got no value. If you put the match or the fire, then only it converts from potential to the kinetic energy. Same way, data has no value unless there is analysis, and that becomes potential to the kinetic value. But unlike fuel, where it gets transformed from one energy to other form of energy, in this data side, one analysis can transform to other richer analytics and more, just like stock. So it just, the comparison as the data as a fuel is not enough comparison. It's like very smart, right? And that's what it's all about. And I'll just go. This is the architecture. I would love you to go through this IoT 4.0 streaming reference architecture. What typically happens, how you have to architect the whole solution set. If you have to develop it by yourself or by your team, you can leverage this particular one. Very open source. You don't see a single vendor stuff over here. Okay, very open source using Kafka streams. And last one is my favorite part, is a pain. What exactly is the pain? Why we need to have a digitizations of the decision making itself. We just cannot be manual looking at the reports and stuff like that. Simple thing, fraud. I know enough of cases where people collect 1 cent, 2 cents out of certain things, and the Nobody notices that, right? Since it's a slow leak, nobody understands what's exactly going on. 30 days later, a peak is being discovered on a number of transactions, and boom, after additional days, it was identified the leak is stopped. What happened? You have a financial loss, brand equity loss, customer loyalty loss. And this is so prevalent in so many things, so many places, right? Having a smart, what is that, checkout systems where you can have a 2 cents out of every transactions going to your bank account. Second one is that, everybody's doing e-commerce. Ad is the most important thing by which you can get the revenues. You change the ad, placement is deployed, and on a specific browser it doesn't work, right? Or doesn't shown correctly. 30 days later, you see a drop in the click, so you lost money. Boom, same impact. Financial loss, brand equity, and the customer loyalty. Very, very normal. Third one, I'll stop here. Change of payment gateway. Great. So unfortunately, it doesn't support the latest version of iOS, which is iOS 14 maybe, right? Wow. 30 days later, you see a drop in the money. And same story. So the question is that all those things already happen, right? So why? So many things can cause your breakdown. Your partner can change. Your device can change. Other external things can change. Company can change, right? Everything can change. So many things can cause your breakdowns or slowdowns. Also, it means an opportunity too. Imagine if you are part, if you can detect before the things happen or the signals, you can be huge. So right now, if you look at the traditional way, the way 99.9% companies are doing, this is the traditional way of measuring your things. This, let's say, dimension of business there, product there, category there, state there, and whatever devices there, right? And you do a manual analysis and all the nice, wonderful reports, slice and dice, blah, blah, blah. You're talking about 40,000 combinations. Nobody can analyze that much. What we need to have an autonomous way to manage the platforms. It will do a detection service and prediction service. It will do self-learning, self-service, real time. And this is what it should do. Train anomaly, root cause, and etc. This is what the digitization of decision making is all about. You know, thing is that if we are not careful, imagine any enterprise has to fight with the startups or the gig economy or the disruptive economies or disruptive companies, right? Why the disruptive companies, so-called some of the companies become successful? Because the companies they're fighting with, they forgot that they have the data, which is the most important about the customer data. They exactly know what the customer wants, but they just didn't react. They just didn't react. Others, the smart wannabes, right? They reacted fast and they made the money. And these guys are dead. So the question is that all this good enterprise company, they have the best assets, which is the data. They can use the same asset to compete against the new gig. And I'm sure if they do it well, they'll be very successful. Have you seen any telephone companies, at least in USA, went bankrupt? No, they're doing phenomenally well. Telephone companies, media companies, they're doing phenomenally well. Why? It's because they exactly know how to leverage the data itself. They know how to monetize. That's it. Thank you. I really rushed it through, and I was supposed to be half an hour, right? I think it's almost like 50 minutes. So, Sabasati, I don't know.
No, okay,
I
sir.
hope
Okay,
it's
sir.
okay.
Sir, it has been a learning lesson for all of us. Okay. Sir, shall I make a query to you? Uh, okay, Tanmay, please.
Sir,
Sir,
I've got a
yes,
single question to you.
Oh, sure, absolutely.
for a country like
Is this
India.
question is the
Okay.
question in the chat there by any chance? Oh, chat, right?
No, sir.
Okay.
Country like India, where
Mhm.
the railways and banking plays a pivotal role, okay, in defining the Indian economy also in general.
Mhm.
So, in your opinion, it will take how long to get the impact of IoT in such sectors? Because our system of Indian system, you told about the way you worked with railways also, okay.
Mhm.
Now, there is East-West Metro. I came to know it operates on the driverless mode. Okay. But in general, in the Indian railways, okay, when they are talking about developing, getting bullet train, etc., in terms of speed, but implementing IoT in a sense, okay, in actual sense, will it be, how long it will take actually? That is my question. Okay, but this is an
No,
area.
I'll tell you, there are two aspects of it, right? For example, transportations and logistics. Railway is all about transportation and logistics. If the passenger safety is a paramount importance, right? Passenger
Yes, sir.
safety always,
Yes,
right? And the safety of the wild animals is important. Already
yes,
things are happening where they have a sensors by which they can detect the elephants or the rhinos crossing the
yes,
railway track, right? And they can stop it, right? So the thing is that there are things, but of course it's a bureaucracy, it takes time, but things are happening. Things are happening on the route optimization as well, because route optimization, as you know too well, the goods train are the most profitable train. Every railway in the world itself, they make money on the goods train. They don't make money on the passenger train. So
yes,
in a given sector itself, instead of having a 20 trains running in a month, can they run 24? Eh, Instead of having each train carrying 24, each wreck or wagon carrying 24 tons, can they carry 27 tons? Right? Things like that. Things
oh,
like that. If we can predict based on the soil conditions, based on the wear and tears of the railway track itself, based on there are at least 89 parameters there, 89, not one, on the
yes,
track itself. And if you can get a sense out of those parameters, then you can very comfortably, very smart modeling can say, yes, right now you're carrying 20 tons, but you can carry 24 tons. And frankly speaking, a very interesting story. Lalu Prasad Yadav, when he was railway minister, he just
yes,
did
sir.
it by his hunch, and as a result of his hunch, because engineer, most of the things are always over engineered, it was able to cater to that. From 16 ton it used to carry the 20 tons. As a result, the railway was flooded with money. It was a hunch, but it's flooded with the money. Now IoT can make that hunch reality, right? So the things are happening slowly and steadily. Things are happening on the railway sides. Banking side, in my opinion, if there's a regulatory authority little bit careful, the ability to the siphoning the money back, what happened to the Axis Bank, can easily be
Yes,
stopped. It's a simple graph theory problem. It's a simple graph theory problems where you have got nodes, and the nodes are finally coming back to you. It's a node and edges, and so it can be very easily. Again, it's a question of will. But what I've seen in the private sector itself, private sector in India, they're doing
yes,
phenomenally well, especially the manufacturing ones, especially the welding ones, especially the transportation guys. They're doing very well with the GPS devices, GPS tracking and analytics itself, and ability to understand the driver's profile, the ability to understand separating the bad drivers and the versus good drivers, ability to see the various parameters. I recently worked with companies where there are almost like a 7 different kind of smart insights we could provide. How the drivers are behaving, how they should behave, and what is the pilferage and so forth. So yes, so technology is being implemented right now, and in the manufacturing side for sure, especially auto manufacturing, absolutely.
oh, so okay, sir. Because in the North Bengal itself, every year, so many elephants and rhinos, okay, they
Yes,
get died because of the railway accidents. If
yes,
that is an area where IoT could be very fruitful,
absolutely,
because you mentioned about the wildlife. Okay, sir.
absolutely.
Thank you. Over to you, Dhanbad.
Thank you.
Yeah.
Thank you very much, Sudeep sir, for your insightful talk. Now we would like to felicitate Mr. Mojumdar with a small e-token of appreciation. For this, we would like to request Padma Shri Professor Dr. Ajay Kumar Ray sir to do the honor. Please, sir.
Sir,
Yes,
if you please stop the screen sharing, then I can share the memento
Oh,
sir email. Okay,
uh,
sir.
that's fine.
Yes, sir. Exactly, sir.
Yes, absolutely, sir. It's fine.
so it's really a pleasure for me uh, to pay my what should I say?
No, you don't have to
Sudeep
say
is
anything, Ajayda. You are my mentor, so Yeah.
So it was a wonderful talk, Sudeep, I must say. And you have touched upon all the areas of IoT. And my dear participants, I can tell you that Mr. Sudeep Majumdar is today one of the, possibly internationally, one of the best, experts, most eminent experts in the area of IoT. And he has long number of years of experience. Not only that, he has been now involved with a large number of projects in IoT sector, not only in United States, but all over the world. In fact, in so many countries, including in India. So yeah, in fact, as a matter of fact, is also a one of our professors, and he is one of our advisors in the JISCE Institute of Advanced Studies and Research. And it's really a pleasure for me to offer our, the great sense of appreciation to Mr. Majumdar for his wonderful talk, for enlightening all the participants on this very important area, which is the area for today and tomorrow. And I'm sure that we will be listening from Mr. Majumdar much more frequently because once, our institutes we start. So thank you, Sudeep, for this. Now it will be almost, 11.
Oh, that's fine. Thank you, Ojada.
United
I always
States.
call him Ojada, so thank you, Professor Roy, formally, but Ojada,
Okay.
he's very close to my heart, and he's my mentor. And I'm so blessed. Let's put it that way. Now, the thing is that Sabyasachi told me it's about 30 minutes, so I just didn't know how I do it. I just went on. So if I would have known that I would be given 1 hour time, I would have paced it out.
Sir,
Frankly
properly.
speaking, how this 1 hour has passed, we
Yes,
couldn't realize. Okay, it was so smooth journey.
That's good then. Thank you. Thank you
Okay,
so
sir.
much.
Okay, thank you, sir.
Thank you.
Thank you, sir.
Thank you.
So,
And please share the slides as well. And anybody, I send the email as well.
yeah,
So suppose you have my slides and the
Yes,
email
sir.
ID.
Yes, sir.
yeah.
So you share, and if anybody have any questions, always I'm there with a phone call, email, whatever, right?
Yes. Thank you, sir. Thank you so much.
So
So
from today onwards, let us start a new journey,
sir. Okay,
Thank
thank
you.
you, sir.
Thank you.
Okay, sir. Thank you. So, proceeding further, I take the opportunity to introduce our next speaker, Dr. Mousumi Chattopadhyay, NIT Calicut, India. She has obtained PhD Theoretical and Computational Chemistry, University of Calcutta, West Bengal, India in 2014. She was Alexander von Humboldt Fellow at Fries Haber Institute for Max Planck Society, Berlin, Germany. Presently, she is Assistant Professor in Department of Chemistry, NIT Calicut. Her research work deals with various aspects of quantum chemistry. So, I would like to request Dr. Chattopadhyay to deliver plenary words. Please, ma'am. Hello, ma'am.
You're not audible.
Audible.
Hello, ma'am.
You are not audible.
Ma'am is unmuted, but
Yeah.
we are unable to hear her. Ma'am is there,
Ma'am, yeah, ma'am is here actually.
but we are unable to.
Yeah, ma'am. Ma'am, your voice is not coming somehow. Ma'am, I think there is some problem in the headphone or like this because nothing is coming.
You directly present from the laptop then.
I think now it's, yeah, it is a bit
Yeah.
audible now,
No.
ma'am.
Bit audible, but it's
Now-
a full.
Now it's audible.
Now it's
All right.
audible, ma'am. Now it's audible.
Thanks for the introduction. So, first of all, if you just see, my name is written here, Rajnandini Chattopadhyay. It's not me, it's my daughter. So, I want to keep it because I am in Kerala right now and I am missing her a lot. So, I don't want to change it intentionally. So, let's share my slides. Okay. So a very good morning to all of you, and thank you to the organizers for giving me a chance to share my research work in this conference. Today I will tell you one of my ongoing works where we find the spin rectification as well as the spin filtration from the same molecule simply by varying its alkyne chain length, right? So before going to discuss the work, let's see some beautiful picture from NIT Calicut in Kerala. So I have recently joined here, and there are three main campuses. The first one is this is a main building where they have administrative section and all. This is the building where registrar and director, all of the administration people are sitting. And there is another campus which is known as East Campus. So our building is rather, the Department of Chemistry is in the East Campus. So I am giving you the talk from here, from the Department of Chemistry. So let's come to the topic now. The work which I'm going to share is related with the spintronics. Now, first of all, what is spintronics? It's basically a spin-based electronics. And as we know that electron has 2 degrees of freedom. One is the charge and another one is a spin. So it is a charge degrees of freedom which carries information in microelectronic devices, right? And the movement or the motion of spins, like the flow of charge, can also carry information among devices, and particularly that branch of science is known as spintronics. So basically, spintronics or spin electronics exploits the function of electron spin in addition to charge degrees of freedom. And there are several probable advantages of a spin over charge. First of all, the spin interaction is small compared to the Coulomb interaction, so interference is less, and one can manipulate the spin by some external stimuli, but charge cannot be manipulated as that easily. So these are the examples of spintronics devices. The first one is here is a GMR based spin bar for read hard drives, and here the second one is a standard GMR based spin bar. Therefore, so spintronics create novel materials and devices whose properties are influenced by spin polarized current. Therefore, we need to calculate or estimate current, first of all, for doing spintronics related research. Now we know that current can be calculated using Ohm's law. And here current is proportional to the applied voltage, right? So we know that V equal to I into R, and R is the resistance of the circuit. And this R furthermore depend on the length and cross-sectional area of the material and is related by this relation here. R equal to rho into L by A. So if L tends to 0, if the length is very small or tends to 0, R will be also equal to 0, right? But experimentally it has been found that the resistance of a single molecule could be as high as 10 to the power 6 ohm. So the question is, what will be the alternative way to calculate the current for a single molecule? So the alternative is here, we can calculate the current of a single molecule by using non-equilibrium Green's function approach. And this is a pictorial representation where a finite and non-periodic molecule is kept in between two periodic and infinite electrodes. Now, if we apply a bias, there's a voltage, let's say in the left electrode, then electrons will transmit from left to right electrode, and during such transmission, it will face several scattering events in the middle part where the molecule is. So in the central region rather, altogether we will get current from the transmission and resistance will give the scattering. Finally, one can calculate the current for such an infinite and non-periodic system using this Landauer-Buttiger formula. And here this G plus and G minus are the advanced and iterated Green's function. I am not going to the very detail of that derivation. So coming to our work, what we did in recent past, we found one work that where a new type of self-assembled monolayers of alkane thiolates, which is kept by conjugated terminal groups, and this type of molecules are basically in the focus of current spintronics research. And recently here, Yuan et al. In their work, they shown how one can control the direction of rectification in a molecular diode. So in their work, what they have done, they considered three different
conference.
Hi, hello.
Audible,
hello.
Yes,
Yes, ma'am. You're audible, ma'am.
Okay, so there was some interaction. Okay, fine. So Yuan et al. In their work, they they just considered three different cases. They have considered this molecule, right? CnFc C13 minus N. So this AFC is a ferrocyanide unit, which is here. It is basically this red color is the iron, and there are two cyclopentadiene, and iron is sandwiched in between two cyclopentadiene, which is known as ferrocyanide unit. And this Cn is attached in one side, and C13 minus N is a number of carbon attached in the another side of the ferrocyanide unit. So what they have in their work, what they have done, they just vary the chain length. That is, they vary N, and they considered three different cases. In the first one, what they have done, they put a non-covalent contact between this ferrocyanide alkane thiol self-assembled monolayer, which is known as SAM, and the electrode. So in the first case, there is a non-covalent contact between the central molecule and the electrode. This is a very strong coupling, right? And this maximizes the rectification ratio of a molecular diode. They found it that if they make a non-covalent interaction between the central molecule and the electrode, then the coupling is very strong, and that can maximize the rectification ratio of a molecular diode. Now, in the second case, what they have found, they made a strong chemisorphed contacts with the electrode through the ferrocyanide group. But in this case, they found there is a leakage of current, and as well as a poor device performance. It's not acting as a rectifier in the second case, the second picture B. So finally, they observed that if they're shifting the ferrocyanide, so the ferrocyanide in the picture one, the ferrocyanide is in the bottom, right? And now in the third case, in picture C, you can see that ferrocyanide is in the top. So what they have done, they just shift that ferrocyanide from bottom to top of the self-assembled monolayer gradually, and they found that in that case, they are getting the opposite rectification. So simply by controlling the ferrocyanide linkage or the ferrocyanide contacts with the electrode, one can control the direction of rectification as well as the extent of rectification. So this work particularly carries an extremely important message that molecular electrode coupling is very important for rational design of materials that rely on charge transport across the organic-inorganic interface. So this has been published in 2015 in Nature Communication. And after that work, there was a theoretical work by Wei et al. And they considered the same molecule, exactly same molecule they considered. In that case, they put this molecule in between silver electrodes. So these are here. These two are the silver electrodes, left and right electrodes, and they studied the transport properties through first principle calculations. They computed the IV curves for each molecular junction. So similarly, they varied the N here, that is a number of alkane chain, which is attached to the ferrocyanide unit. So they varied that number and they calculated the transport properties, and they found that while taking n equal to 13, then it behaves as a spin rectifier. But if they are taking n equal to 8, although they are getting high current, but they didn't find any rectification feature. So what we did, now coming to our work, with this background, we have selected one self-assembled monolayer where we simply replaced. So if you remember, I was saying that ferrocyanide unit. Now what we have done, we take the same thing, but instead of cyclopentadiene, we put benzene here. So our system is CN-BZ. It was, in their case, it was a cyclopentadiene, then iron, then in that case there was a cyclopentadiene. In our case, it is benzene, and other units are same. So just cyclopentadiene is replaced by benzene, and we replace it, and we want to. So this is our picture. This is our molecule, and this is a picture of the Bayer molecule. So we keep first we select this molecule, we optimize it, and then we put it in between two iron electrodes, and this is a two-probe configuration of the whole system. So the first one is we want to check some two things from here. The first one is how the transport property is altered by varying the number n. That is a length of the alkane chain. And the second one, which we like to see, that what is the impact of benzene instead of cyclopentadiene on the transport properties. So aiming this, what we have done, this is a just briefing of the calculations which we have done. We first optimize the geometries of self-assembled monolayer of benzene, keeping the value. We consider three different values of n. So we considered n equal to 2, we optimize the system. We considered n equal to 4, we optimize that system. And finally, we considered n equal to 6 and we optimize another system, that system. So we have three systems altogether. And for each of the case, we considered the +2 oxidation state of iron. So if we consider that one, the iron can be in high spin and as well as in low spin state. And in each of the case, we found that it is a high spin state, that is a quintet state, which is more stable over the low spin state, right? And so we performed all the optimization related calculations in Gaussian using hybrid functional. In the next step, we put this optimized geometries in between two iron electrodes, as I shown in the previous slides, the two-probe configurations, and we optimize the whole device again using quantum ATK. And finally, we perform the quantum transport calculations in the density functional theory. So, and we used PB functional for that and double zeta basis set. So next, for transport calculation, we used this Landauer-Buttiger formula. So these are the results here. These are the IV plot for self-assembled monolayer of benzene. And the first one corresponds to n equal to 2. Second one for n equal to 4. And the last one is for n equal to 6. Now the first figure for n equal to 2 particularly indicates the rectifying nature of spin polarized current coming from the up spin channel. And this feature is pronounced at a bias of minus 0.8 volt as well as in the two extreme bias, 0.8 volt. And the estimated current here is like 66 for positive bias 0.8 volt, it is 66 approximately, and here it will be roughly around minus of 280 nanoampere. So therefore, the molecule for n equal to 2 while sandwiched in between two iron electrodes can behave as a molecular rectifier, and the rectification will be approximately equal to 4 within the bias range of plus minus 0.8 volt if you consider those values of current. Now, if you look here in this rectification process, only the up spin electrons are participating, or only contributing. So it is a case of spin selective molecular spin rectification. So we found that considering the molecule, if we consider the molecule and if we just change n at 2, if we consider the alkane chain length at n equal to 2, then that particular system can behave as a spin rectifier. Now, if we take the value of n equal to 4, then you can see here that it is a spin filter, and it is a second picture here. And we calculated the spin filter efficiency for all of this system using this formula, where these are the transmission coefficient for upspin, and this is a transmission coefficient for the downspin electrons. The spin filter action is clearly evident from the nano device. You can see here that it's a very good spin filter. But whereas in this case, it is not a spin filter. This is a spin filter here. And so the IV plot, if you look at the last one for the n equal to 6, the IV plot is not very significant. It is not a spin filter, not a rectifier, not a valve. I mean, so we drop n equal to 6 cases here. Although I am presenting, I just want to tell you the message that if I vary the alkane chain length from n equal to 2 to n equal to 4 to n equal to 6, it's not very important as far as quantum transport properties are concerned. While for n equal to 2, it is a spin rectifier. For n equal to 4, it can behave as a spin filter. Now we checked whether this current rectification for n equal to 2 state can be used as a source of spin current rectification or not. So the rectification action which we are getting here, it is coming from the charge current. Now we want to see whether it can act the same unit, right? N equal to 2 can act as a source of spin current rectification or not. So what is a spin current rectification? It can be for asymmetric molecule. It can be broadly divided by two categories. One is the weak rectification and another one is the strong rectification. So weak rectification is the one where the reversal of the applied bias reverses the direction of spin current and alters its magnitude too. It is very similar with the charge rectification, but in strong rectification, it is not the case. In strong rectification, it has no impact. It is not altered. The spin current direction is not altered by reversing the applied bias. So these are the, excuse me, I think it should be written here, charge current, that is missing here. So sorry, in the left hand side, it should be charge current here. So this is the charge current and this is a spin current for all of this system, n equal to 2, n equal to 4 and n equal to 6. So we recognized that if we choose n equal to 4, okay, let me discuss something here. The charge and spin current, so this is the charge current, this is the spin current. Well, and in case of the charge and spin current can be calculated using the formula. Okay, here the charge current can be calculated using the formula here, and the spin current can be calculated using the formula here. So you basically use this formula for calculating this. And the spin current rectification ratio for n equal to 2, the green line here, is very high, and it is as high as 4.23 within the bias window of plus minus 0.8 volt. Now, if we increase the applied bias, we can increase the ratio. So what I want to say from here, that after getting the rectification action from n equal to 2 keeping n equal to 2, we have separated the total current as charge current and spin current. And we found that yes, for n equal to 2, if we calculate the spin current, then also that rectification action is maintained, and it is giving a very high rectification ratio. So this is a spin filter efficiency which we have done for all the system n equal to 2, n equal to 4 and n equal to 8. Efficiency is for n equal to 4 is 93.66%, and the spin filter efficiency is we are calculating at 0 bias. So we need to check it for the finite bias also. So we check the spin filter efficiency at finite bias, and this is known as we are checking the spin filter in spin, which is plotted here. So, hello.
Yes, carry on.
Yeah. So the bias, one can calculate this BDSIC, which is the abbreviation of bias dependent spin injection coefficient, using this particular formula, where I is the current from the spin up channel and I spin down is the current coming from the downspin channel. So if we are plotting for 3 different states n equal to 2, 4, and 6, we are getting this one, and you can see it is very high for n equal to 4 only. That is the pink color, the pink curve here. So that the n equal to 2, when we are considering the molecule for n equal to 2, it is giving a very high spin filter efficiency, that is of 93.66%. I regret that I should write it here. And when we are calculating the BDSIC, that is the spin filter efficiency for finite bias, we are getting very good values. So it is it is reaching a positive values up to 86% here, the maximum point. So we can see that this n equal to 4 state, n equal to 4 can act as a very good spin filter. So now what we have done to make some real conclusions, we have calculated, we tried to find out the origin, why these systems and how these systems are acting as the spin rectifier and spin filter with alteration of the alkane chain length. So first we have we analyzed the density of states, projected density of states as well, and this is a total contribution coming from the whole system, mainly from the central region, and these are the p orbital contribution which is coming from the carbon atom, and this is a d orbital contribution coming from the iron atom. So if you look at this plot, these two, the total orbital contribution and the p orbital contribution of carbon atom looks very similar. It means that in the total density of states, it is the carbon p orbital which is contributing mainly. So, and if you go here in the d orbital contribution of iron atoms, it's very there is nothing near to the Fermi level. So it means that d orbital of iron atom is literally do not participating in the transport calculation. It is the carbon p orbital which is contributing, and the maximum contribution is, or the sole contribution is coming from the carbon p orbitals only. This is why you can see the density of states here only in this region. And we have done this calculation only for a particular bias, minus 0.84 and plus of 0.84. So this is for the n equal to 2 states, right? It is written here. So the upper panel here shows the density of states for n equal to 2 at minus of 0.8 volt, and the lower panel here shows the density of states for n equal to 2 at plus of 0.8 volt. The first one is these two are very similar picture. You can see from here, but as we are getting much higher current at minus of 0.8 volts, so obviously density of states contribution is also very high. We have done the same analysis for n equal to 4 state 2, but I am not going on to that detail. So you can, what you can see from here, there is a very important observations we got from here, that although there is a there is a iron transition metal, iron is present in this particular system, but surprisingly that iron 3d orbital, which is vacant and which should participate in the quantum transport process, but that is not participating in the transport phenomena. This is a very important observation, and this is an example of a metal-free magnetism, where the transition metal is not participating in the transport process. So when we have done the similar analysis for n equal to 4 states, we have we found the same thing. I mean, even for n equal to 4 state also, the iron d orbital is not participating in the transport process. It acts as a good spin filter, but it's a spin filter where there is no contribution of iron d orbital. So next we analyze the transmission spectra of the system for n equal to 2 state as well as for n equal to 4 state for this particular voltage of plus minus 0.8 volt. And the transmission coefficient within the defined bias window is larger at minus of 0.8 volt compared to its positive counterpart. You can see that there is a large peak within the bias window here, which is absent here. And this is the origin of observed spin rectification ratio in the self-assembled monolayer of benzene. So, okay, this is a spin. You can, if you just compare, if you can remember that curve, that IV curve, the current was coming from the spin up channel, and the current was high at a particular bias of minus 0.8 volt. And you can see that thing clearly from here, that there is no transmissions. The transmission coefficient is almost 0 for the downspin channel, no contribution. Whereas for the upspin channel, there is a contribution for both of this, like minus of 0.8 volt and plus of 0.8 volt. But if you remember the IV curve, if you remember, then the current for 0.8 volt was very low, but the current for minus 0.8 volt was high. This is why there is a large peak here within the bias window, which is absent here. So we have done the similar calculation for n equal to analysis for n equal to 4 states too, and it's a self-explanatory one. So finally, we analyze the molecular projected self-consistent Hamiltonian states, which is known as MPSH states. And the first one is here for n equal to 2 states, and the second one is here for n equal to 4 states. And similarly, like all other analysis, we have considered only the two terminal voltages, as the current is high, and we are doing all the analysis. This is why we are doing all the analysis for plus minus 0.8 volt only. So if you look at here, the MPSH states, the upspin channel, current from the upspin channel is very high. This is why you can see it from here, and the current from the downspin channel is low, which you can see from here. So the MPSH states developed due to the, when you are putting the central molecule and in between two electrodes, then there is a interaction between molecule and electrode. So the MPSH states develop due to that molecule electrodes interaction. And so these are this is for the reverse bias, this is for the forward bias, and it's just explain the current is here. We got the current very high current, and in this case we got less current. So you can see it from here. So these observation basically these are the singly occupied highest molecular orbital of the system, and if they are extended through as high they will extend, it means that the current will be high. So in this case, it is spread over a long region. It is spreading from a large part of the molecule to the electrode. So the current is high for minus 0.8 volt. And if you look here at 0.8 volt compared to this one, the molecular projected self-consistent Hamiltonian states are not that much spread, it less spread than this one. This is why the current in 0.8 volt is less and minus 0.8 volt is high. So similarly, it is a same thing for n equal to 4, where we found a spin filter action. So basically, this observation corroborates well with a highly localized, singly occupied highest molecular orbitals as obtained at like minus 0.8 volt. So I am concluding here that we studied multifunctional transport properties of iron 2 complex and explained them in terms of current voltage calculations, density of states, transmission coefficient, implicit states analysis, and we have done few other calculations like transmission pathways, and I'm not showing it here. That's the same thing we are getting, that if there is like mainly constructive interference, it means that the current will be high. And the complex system which we considered here displays molecular spin rectification. If we are considering n equal to 2, that is here, if we are considering n equal to 2 states, if we increase the value at n equal to 4, the behavior is getting altered, and the complex from spin rectification, it's changed from a spin rectifier to a spin filter with an efficiency of 86%. But if we consider n equal to 6, if we increase the chain length again, then we didn't find anything significant. So thus changing the alkyne chain length of the iron 2 complex, the spin transport can be dynamically altered from spin rectification to spin filtration. So this is an example of a molecule where you are getting, where one can see from the same molecule, one can see the rectification as well as spin filtration simply by altering the chain length, by varying or by tuning or by controlling the chain length, right? And in that case, we have found that the d orbital of iron is not participating in the whole quantum transport process. That is also a very good observation, because in general, if there is a transition metal which has vacant d orbital, they are participating in the transport process. Electrons are transmitting through the vacant d orbital if available. But in this case, they are somehow they are not participating. We need to do some further analysis to check what is the particular reason why the d orbital of iron is not participating, whether it is out of plane with the total central molecule, why it is not available. That we need to check. So we will do some further analysis. This is an ongoing work, and I would like to acknowledge Dr. Shobbashachi Sen and Rinki Bhomik from the same JISCE college, because this is a collaborative work with them. And once the work is almost done, there are few analyses which we should do, and after that it will be complete. So thank you very much for all of your kind attention.
Thank you, ma'am. Thank you for your such an informative presentation, and also you are looks like a family member of JIS. And now, yeah, exactly, ma'am. Now I would like to request Dr. J.K. Mondal, Professor, University of Kalyani, India, and he is also Program Chair of IOCER COVID-19. If you please deliver a memento of appreciation to ma'am.
Hello.
Yeah.
Please share that.
Yeah, exactly, sir. I'm sharing. Yeah, please, sir.
Yeah. So I am honored on behalf of the JIS College of Engineering and entire fraternity of JIS group. I used to offer the appreciation to Dr. Mousumi Chattopadhyay for his illuminating talk and latest trends of research in this area. Madam, please accept our appreciation.
Okay. Thank you, sir. And thank you, madam. Thank you, madam, again for giving us your valuable time. And also, sir, Dr. Mondal is one of the pillar actually of this conference actually. So now, again, it's the time for our program chair of IOCER COVID-19, Dr. J.K. Mondal. So moving on, he is the next distinguished dignitary, Dr. J.K. Mondal, Professor, University of Kalyani. Dr. Mondal completed his PhD from Jadavpur University in the field of data compression and error correction techniques. Presently, he is professor in Computer Science and Engineering Department, University of Kalyani, India. Honorary Director, IQAC, University of Kalyani. Life member of CSI, CRSI, Associated Member, ACM IEEE. Fellow member of IETE, and ex-dean Faculty of Engineering, Technology and Management. Recently, he is working in the field of network security, remote sensing, and GIS application image processing. He has 32 years of teaching and research experience. So, I would like to request Professor Mondal to deliver plenary words. Please, sir.
Thank you, Tanmay, for your introduction, and I'm honored for inviting me to associate with you for this program. So I'm sharing my PPT.
Yes, sir, it's visible.
Visible?
Yes, sir, it's visible.
Yeah. So in this session, I am going to give a glimpse of software-defined network and security issues. Now it is the latest generation of the network. So what is our existing classical network systems? We have in this classical network system, we have a foreground and background communication system, where in the foreground, most of the cases, we have a star networks and background bus networks, and we have a memory. If we have a managed switch, then we have some memory. So background transmission is based on a queue-based memory management system. And you see that when we purchase some switches from the vendor, so it is a vendor specific configurations, vendor specific operating systems, vendor specific software and control program. So that is one of the major drawback of this current scenario of the networks. So this is the extended view of this FOUTP networks. So when I am going for the 4-plane communications, so normally the channels are multiplexed within your lab, and when I am going to switch to switch or from one switch to another switch, then definitely background and backplane communication is there. It is just queued on the memory and it is transferred. And how it is transferred, we have some routing tables, we have some routing techniques, which is ported by the vendor into the system itself. So if I have a Cisco switch and I have another switch is from HP, now you see that there may be some compatibility problems, and the two control softwares into switches are different, portabilities are different, platforms are different. So the research are going on for unifications of this same. So now mostly the active networks are working, the switches are they have the algorithms and other things are ported, and the routing tables are static most of the cases. And what are the difficulties? The difficulty of integrating new technology, and then poor performance due to redundant operations in the several protocol layers, and difficulty in accommodating new service. And you see that waste support is a specific vendor-based waste support. That is the major problem of these networks. And you see traditional routing, so it treats all bits the same, and average utilization is 30 to 40%. So bandwidth cost is also high wastage. Now, what is the software-defined network? It is the restructuring of current network infrastructure for improved network management. It is not a new technology, but reshaping the current network, where we are separating the control and data plane. we are decoupling the control plane and the data plane. So software defined network is an emerging architecture that is dynamic, manageable, cost effective and adaptive, and making it ideal for high bandwidth dynamic nature of this application. So main theme is that the network control planes forwarding functions are decoupled. So what is the control plane? The control plane is the module which take all the decision. Basically is instructor, all routing algorithms. And what is the data plane? The data plane is the module which carries out the task given by the control plane. And it's forwarded the packet based off the task on the dynamic basis or adaptive basis, not fixed in any cases. So let us consider the normal scenario. You see that user 1 sends some data to user 2. Suppose is using this route. So this is a fixed network. So suppose this switch goes off. Neither this receiver nor this sender has any idea or has any measure to take. That means, so global view is absent, or the switch has been attacked. I don't have any idea about that. So if I have a problem, if it is a sync node, then I should avoid this. So I don't have any mechanism of this switch here, because we have some static routing table and routing paths and IPs are fixed here. So no centralized control is available. That is the problem. User cannot control it. And all the application ways hardware are as a single bundle in all switches. What you have seen inside the box, that are the switches. So the limitations are the vendor specific architecture of switches limits the dynamic configuration according to application specific requirements. And you see, switches are required according to the installed operating system by the vendor. You cannot change it, or vendor cannot change as per your requirement. And secondly, the centralized control is not feasible in your traditional network system. So, and you see, this routing mobility management, cost expensive, and millions of gates and thousands of lines of codes, multiplicity of the codes in multiple places of the nodes. This is the current scenario of the network, and these are the problem of the current scenario. Now, what does separating control and data plane mean? What is the meaning that I am separating the data plane and the control plane? Here, the vendor only provides the hardware, that means the data plane. We decide the control plane by writing the custom logic and the software, and the routing rules and all these things. What are the advantages? So features are no longer limited to what the vendor provides. So community development, longer life of products. If some control ways is obsolete, so I can port it with some other ways, with some other latest means of control software. So I can put the software from any vendor, I can put algorithm from my own. So that is called the separating control and data planes. How does SDN work? Compared to traditional network, a software-defined network has two types of devices. One is called controller and other is called switches. The switches in the SDN is completely blind. There is no control software, there is no control ways, there is no routing tables, so no built-in feature. So need to be instructed by the controller. So let us consider a scenario of SDN controller. So SDN controller is called the brain of the network. All policies, routing logics are placed in the controller. Teaches the switch what to do with an unknown packet. That means the packet is coming, but the principal will be forwarded by the controller, unlike your normal switch. So you see, let us see a scenario that I am trying to send the data from H1 to H3 in SDN environment. So what will happen? You see that your source is H1 and destination is H3. So the switch is blank. Controller is there. So it has come. Now you see at the beginning table is missing. No rule is there for H1 to H3 at the beginning. So the controller will give the rule and packet will be forwarded. So the controller generates the rule based on a software program. So logic may be different. So packet is buffered. And then based on the rule is installed at the TCAM hardware of the switch. Then based on this rule, the packet is forwarded. So it's a complete dynamic situation. So buffer packet is forwarded based on the rule. So all the future packets from H to H2 follow the same rule until the rule is changed. If needed or required, rule may be changed at any moment. But in normal switches, we cannot do it. Normally, we have 3 layers in SDN architecture. We have application layer, control layer, and data layer. So under the data layer, we have the forwarding devices. And we have the operating system in the control layer, and in application layer, we have traffic engineering, routing, and security. And we have 2 API here, northbound API and southbound API. So you see that we have the controller, we have 2 API, northbound and southbound, and we have 3 layers, application layer, control layer, and infrastructure layer. You see, these 3 layers communicate using respective northbound and southbound application programming interface, that API. You see, we have the application layer, maybe load balancer, firewall. So in southbound, we have the local infrastructure. That means your system, your switches. So these are the SDN architecture. Now, how your SDN works? The SDN encompasses several types of technologies, which include functional separation of network, virtualization, and automation. So mostly you're separating the data plane from the network control plane. And your data plane physically moves data from one network segment to network, other network. So network control will make the decision how packets are flowed. And what are the benefits? You can deprioritizing the specific network traffic. You can generate the rule. You can exclude some nodes if you have any problem. You have high granularity of the control, end-to-end network management, end-to-end network visibility, but we have the centralized controller-based policy management. So how we implement this SDN then? OpenFlow is considered one of the first software-defined network standard. It is originally defined as a communication protocol in SDN environment. So this, we have the applications, we have the network operating system, packet forwarding, we have already discussed all these things. So what is OpenFlow? OpenFlow is a protocol controlling the forwarding behavior of Ethernet switches in a software-defined network. It was released by Clean Slate program at Stanford, and it is maintained by Open Networking Forum nowadays. So it is a layer 2 communication protocol that gives the access to the forwarding plane of a network, switch, or router. So, but SDN is not all, is a part. So OpenFlow enables the network controller to determine the path of the network packets across the network switch. And controller is separated entity and is distinct from the switch or interface. So it helps in a sophisticated traffic management unlike ACL. So OpenFlow allows remote administration of layer 3 switch packet forwarding table. And this is achieved by adding, modifying, removing packets, matching rule and actions. That means rules are generated dynamically based on your program, based on your situation, based on your detection of intrusion in a network node. All these things I can go for in adaptive manner. So your OpenFlow protocol is a layered on top of the TCP, top of the transmission control protocol, and it's prescribed the transport layer security. And controller always listen on the TCP port 6653 for switches that want to set up the connections. And for the communication, OpenFlow is used. So OpenFlow is not complete or not SDN, is a but is a favor of SDN network. So this is your switch. We have control path, we have the data path, we have the OpenFlow controller and OpenFlow API. So these the working of the OpenFlow. You see, this is an example that we have the OpenFlow client, we have source, destination, we have various Ethernet to the systems or computers is forwarding like this. Now let us see the scenario of SDN. Suppose Bob is forwarding using this path. Now Alice is forwarding with this path. So that means the path can be dynamically changed. So routing table is not fixed at a particular switch. It is based on the control line. So suppose there is a problem of a particular node. We can change the routing scenario and that table. That means I am just decoupling the data plane and the control plane in this network scenario. So these are, so you see, when you are going for the OpenFlow tables, you are giving the rules. So various rules we are giving. Then we are giving various action, how the packets are forwarding, how the packets are encapsulated. So how packets are dropped, why when packets are dropped, then computing the statistics, then you are defining the priority, you are defining the routing tables on dynamic manner. Also the priority of the rule. So you see some example of these tables. So you see from forwarding port, then you see you are coming, someone action is taken to the Ethernet, someone it is stopped. Now we have various security issues in this SDN scenario. We have flooding and DOS attack, we have host hijacking attack, we have tampering attack, we have spoofing attack. So flooding attack. So attacker may devise a DOS attack to make the controller down. So if controller is down here as a centralized management system, so everything goes down. So there may be a major problem in the SDN scenario. So now what is the other attack? Suppose host hijacking attack. It's a spoofing attack by exploiting host tracking service. HTS is a network-wide view and essential service in SDN controller, which may be hijacked, then it may be a problem. If we simply go for the controller and the data plane connected by a centralized control system, we may have tampering attack, where your northbound and southbound API messages are used to manage the network. So if the messages are the malicious or the tampering attacks are there on the northbound and southbound API, so all the network system will bound to malfunction. That is, the flow of traffic across the SDN may lead to a disaster random attack. There may be a spoofing attack. The attacker can create and update the entries of flow table in the SDN network. So that has to be prevented. So these are some of the scenarios. So now, how do you manage the controller in the SDN? So it is a very recent work, some of the works of some of our scholars from our lab we are doing. So you see, if we go from a BRS, that means backup and restore systems. I have the controller, I have the switch or a data plane. So I have a BRS. Suppose I'm using a single BRS. Then if BRF is acting as an agent, detecting the intrusion, all these things, integrating like this. So this is the SDN scenario with BRS. We have the SDN controller, we have the subnets, and we have one BRS. So if there is a problem in any subnet, now BRS will take the charge of that, and then it will restore the original situation, then it will give the control back to the. This is one scenario. How we will go for it? Here one techniques are there. We go for giving some arithmetic coding techniques or various coding techniques for inconsistency detections. Later on I'll come to some other detections. So you see that we have the standalone controllers. So there may be a problem in the standalone controllers. Then some architectures are proposed in terms of BRS using master slave controller. You see that we have a BRS as a backup and restore system. We have a master and slave controller. So I know how you know how the master slave controller works. What is in the master copied by the slave. So if slave is compromised, master can take the action. If master is compromised, slave can take the actions. If both compromise, either compromise, BRS can take the actions. So we have a triangular verification techniques or triangular verification methodology for inconsistency, hijacking, spoofing, or syncing the nodes of the data plane. So this is some of the standard architectures. So that means what are the steps following by this? Controller failure detection, authentication, and recovery process done mostly by the BRS based on the master controller or master slave controller. Yeah, these some of the methodologies are there. It detects the failure. If it sends a request to the topologically adjacent controller to manage the subnet, and then after restoring the scenario, they used to give back the control. So this is the functioning of the BRS. This is one of the arithmetic coding techniques. I'm not just time is short. Yeah. Now, in the latest recent trends, that lot of blockchain methodologies are being used for your detection of malicious activity on the controller. So it's an important system BRS is managing. But if there is a problem in the BRS, so who will do that? How it will be done? So you see that I can use a blockchain for two-way authentication systems where each block contains a cryptographic hash related to the previous block with a timestamp and transaction data. And it's an open distributed ledger that can record the transactions. It's a typically part-to-part network managing this. You see that we are giving a chain into a block into the controllers. So these are devices, infrastructure, and you see replicated blockchains. How the hash functions can be generated. I am giving a very simple glimpse. Suppose the hash for the first block is a random number. Then this is an example. So I am keeping it in the BRS. Then I am going to the next controller, who is managing a subnet. I am putting the next value computed from the previous value. And there is a relationship. There should be, because otherwise blockchain will not work. So how? I am giving an example on that. Suppose I am going for, suppose this is a binary number I am putting in a BRS, in the BRS. So what is the decimal value of that number? It is 85. What is the position of that 85 in the odd series? I am just taking the series. Odd series, it is 43rd odd. Okay, and I'm keeping some control measure on the BRS as well as on the controller. Then in the next, I am putting the, if it is 43rd, so 43rd is, what is the position in the series of natural odd number? 22nd. So I am keeping 22nd in the next. That means the entire block is recomputable. So suppose now how authentication is done. I'm just giving you. Yeah, this is like this. So I am going for a two-way authentication. That means I can compute clockwise and anti-clockwise. I am computing the clockwise and anti-clockwise. So in both way it is recomputable. So in both way it is recomputable. Now, when I am computing, if there is an inconsistency on that particular node, so it does not match. From that, I can take a scenario that there may be a problem in the situation. So the chain will be withdrawn and backup BRS will act, is functioning, and then rest of the work will be restored and another chain will be added based on some other policies. So I can go for multiple chains. I can go for number of chains into small segments. Oh, 2 minutes wait first. So the blocks are the blocks are like this. You see, I am giving a blocks here, the chain of these blocks. So another chain I am giving, but there is correlated and interrelated. So I can go for a good authentication. So the security is, the challenging situation is that the security both the benefit and concern with the SDN technology. So another challenge, there is really no established definition of software defined network in the industry. Still it is coming. Still it is coming. So, but what is the scalability of the network, change of the scenario of the network, change of the position of the network? Anytime I can migrate one network system infrastructure from one place to another place, complete, but not taking the physical fabricated things. So that is coming. So that's why all IoT based systems and other systems nowadays we are using SDN switches. So nowadays this is the scenario of the future days. So now what is in the summary? SDN encompasses several types of technologies, including functional separation, network virtualization, automation through programmability. So originally the SDN focusing on separation of the control plane and the data plane. So in classic scenario, packet arrives at a network switch, rules built into the switch proprietary. So suppose today in an SDN systems we have one operating system. Now tomorrow I can use other operating system. So that are the major benefit of the SDN scenario. These are some of the references from where I have prepared this, and some of our research works published in some of the journals available. So these are in short the SDN architecture, which is the future trend of the network. Now I can go for some questions.
Yeah. Thank you, sir. Anybody of you have any question, then you can ask to sir. Okay. 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 Thank you. Thank you so much, sir, for your nice presentation. And actually, the organizing committee and the entire family of JISCE conveys our heartfelt gratitude to respected Professor J.K. Mondal for being the pillar in organizing this kind of conference. And now I would like to request Dr. Papun Biswas, Dean Innovative Learning, JISCE College of Engineering, and also convener of IOCER COVID-19, to deliver a memento of appreciation. Please, sir.
Thank you, sir. Nothing to say, actually. Sir is the main pillar of this conference. So whatever we have done in this conference only because of J.K. Mondal, sir. So still, sir, on behalf of the organizing committee, I just handed over this beautiful memento to you. Please accept, sir. And in future also, we just want your guidance to organize this kind of conference. Thank you.
I am honored to accept this memento. I am honored for inviting me to associate with your activities. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you so much, sir. Okay, sir. Thank you. And now, participants, we are now heading towards our parallel session. That means a technical session 4, 5, 6, 7, and 8. So all the presenters are requested to join in their respective sessions according to the program schedule shared. Session coordinators are also requested to do the needful. And please note that we will join again in the technical session 9 invited top sharp at 2:30 p.m. So it is a request to all the session coordinators, please try to finish your session on or before 2:30 p.m. Okay, so that's all for this session. Thank you.